Hill and Austin Dudas. One of them has a brother got married, so that was a pretty good reason not to be here for this. So we'll have them on the schedule also. I just don't remember where at the moment. So what I was going to do is step through with you on how to create a project in Visual Studio, how to get the files you need, etc. Professor Darden is going to do the same thing for Xcode. The person who usually does a Sublime demo, which is Oliver, isn't here, but he wrote a guide up that he posted on Piazza, and we've got someone on staff getting a copy of that and reposting it on Piazza. So we don't have a demo ready for Sublime tonight, but we'll have the guide posted on Piazza at some point. So what I'm going to do is, I'm going to show you in Visual Studio, and there's one thing that I changed in the Visual Studio document on how to use it. There used to be a thing in the Visual Studio document that said, uncheck this box, don't create an extra directory for the solution. And what I discovered was that the enterprise version and the community version do things differently, where in the past they've always been the same. Well, now they do something differently, which makes it really painful to uncheck that box. So now the guide, the big change I made to it like today says, check that box. So let's go through creating a project, and I'll show you what that part is when we get there. So I'm going to say create a project, and then there's one other big difference between the Visual Studio Enterprise and Visual Studio Community is this very first screen. On Visual Studio Enterprise, you're going to say, I want to create a Win32 console application. When you're doing it on Community, you'll say, I want to go through the wizard and create the project myself. The other thing that's different about them is, again on this screen, is the default location. So the default location for the Enterprise Edition is in your Documents folder, Visual Studio 2017, Projects, and then it creates a new folder for every project inside of there. The Community Edition defaults to your user folder, source repos. The location isn't critical. It can be anywhere. It could be on a flash drive. It could be on a shared drive. It could be on your Google Drive that's attached to your desktop. You just have to remember where you create your folders and where you create your projects. And once you change this, if you say, hey, I want to create this, this project folder on my Google Drive, once you make that selection, it'll stay that way for the rest of the time you're using Visual Studio. If you change the checkbox here that says create directory for solution is the one that I said you should start checking, because if you're using Community or Enterprise, if you don't check this box, it's different for the different versions. If you do check this box, it's the same how they create the folder for the project, and that makes it a lot easier for the staff and for you to find things. So I'm going to leave that checked, and I'm going to say, hey, I just need to give this thing a new name. I don't want to call it console application. Is that? Okay, it's not terribly legible at this size, but you can tell where I am. So we're going to give the application a new name. I'm just going to call it Project 0. Hit OK. And then, this one's really important, do not hit finish here. Go on to the next page, and the window will be slightly different in the Community version, but it has the same options. So we're going to go to the next page, and we're going to uncheck precompiled, and we are going to check empty. If you don't do those two things, it'll create some standard AFX files, etc., that the autograder won't understand and will produce grief for you. So if you create a project and it has the standard AFX files, you know you created the project wrong. The downside is these options you have to remember. Every time you create a project in Visual Studio, you have to change these options. The which folder and the create directory for the solution, those will become default settings. You won't have to change those every time. But this one, uncheck the precompiled headers, do check empty project, and then say finish. And then after a few seconds, it gives you sort of a blank screen. We've got sections over here for source files and header files, And if you were going to create a project completely from scratch, you would start by creating new files. But for project 0, which we've got posted on Canvas, there's already some starter files. So let's go over there. It's got project 0 starter files. Okay, no preview. Let's download it. And this is one thing you're probably going to want to install if you've got a PC. Install something that understands tarballs and zip files, etc. I use 7-zip, is free. So I say open it with 7-zip, open that up, and here's everything. I'll just select all of them and say extract. Now here's where we have to start remembering, where did I put stuff? So I don't want it in some temp folder. I want it to go in my Documents folder, Visual Studio, 2017 projects, and let's scroll down. Which project? Project 0. And then it keeps scrolling on me. Notice that there's Project 0 and Project 0. This is what happened when we said create directory for solution, is that we got 2 Project 0 folders, one inside the other. We want to put our source code in the inner folder. So we want to put our source code in the inner folder. We want to put our input files in the inner folder. Everything goes in that inside of those double folders with the same name. So I'll say put it there, okay. And it didn't say anything, so it must be done. Now let's go over to Windows Explorer. I've got my Visual Studio Projects folder open here. If I look in Project 0, notice there's a solution file and the Project 0 folder. If we look inside Project 0, it's got everything that I just downloaded. My make file, my Project 0 CPP, my sample input files are all in this folder. So they are where they should be. If we go back to Visual Studio, we can right-click where it says Source Files, say Add, and now, like I said, if we were creating a new project from scratch, we would say add a new item, like I want to add a new source code file. But for this one, since we gave you some starter code, I want to say add an existing item. Now that existing item is going to be my CPP file. Now that adds it to the source code, and if I double click on that, it opens up the file in the editor and I can look at it. Now, there's one problem with Visual Studio. Every IDE has some problem or another. So now we've got to deal with the problem with Visual Studio. The problem with Visual Studio is that something that we need this semester for basically every project is called GetOpt. GetOpt, Visual Studio does not supply it. I don't know why, but they never have. So the document on installing and using Visual Studio tells you the steps to go through to get getopt.h into the compiler folder. And if you can't get that working, there's 2 alternatives that it outlines. If you have trouble with it, I'm going to stick around tonight. If you've already tried this and couldn't get it working, I'll help you out. If you come to professor office hours, I can help you there. So getting the header file in place is something we only have to do once, and then we're all set. Once it works, it's good. However, there's 2 parts to it. There's a getopt.h and getopt.c. Now, the header file is the hard part. You only have to do it once. The .c file, the source code file, is the easy part, but you have to do it every time. So I'm going to go back to Canvas, and I'm going to go over to my Files, Resources, Visual Studio Files, and there's getopt.c and getopt.h. So I'm going to take this and download it. So I'm going to save a copy of this, and I could just put it in my, like right here, look, my default location is my 281 Fall 18 folder. I could put it in my download folder. That would be an easy place to put it. I could just go put it in my project folder. So I could just say, hey, put it in my documents, Visual Studio, projects, project 0, put it in the innermost folder there, save a copy of it. So that step you have to redo every time you create a project that deals with the command line. We have to make a copy of that file. So go back to Visual Studio. We're going to right-click Source Files again, add existing, and we're going to add getopt. And it says there, this is a C source code file. So we'll add getopt to it, and now we should be able to say build this solution. Start noticing the function keys, like my setup says F7 is my build button. Start getting used to those. It'll be faster if you can just hit F7, F8, F12, etc. when you need to. Okay, so this says at the bottom it succeeded. So this project built correctly. Let's try running it. Oh, error, no mode specified. So some of this code is already written. There's a lot of code already in this file, and one of the pieces that's in there is dealing with the command line. So the idea with the command line is when I run a program, let me increase my font size here. Okay, so normally when I run a program, I might say type /project0. And I could hit enter and it would run. But what if I want to tell this program, hey, I need to do something special this time? Like if you've used Unix at all, you might see the ls command and you can do ls-l to say I want a long listing of my files. So what our projects do in this class is we need to specify things on the command line. So if we were running it on Kane, we could do it by typing it, /project0, etc., and fill it all in for the parameters that we want to give it. In Visual Studio, however, we have to know how to do it. And this is in the How to Use It guide. We right-click on the bold project name. So where it says up in the upper left, Project 0 in bold, we right-click on that, go all the way down to the bottom to Properties, choose the Debugging Properties section, and then go over to where it says Command Arguments. Now this is not the name of the program. See, this is everything but the program name. Visual Studio already knows how to run the program. We've got to give it the extra things that will appear on the command line. So for instance, this project has one flag, -m, and I'm going to give it no size. And we'll look at what it does in just a minute. So I'll get that all ready. And then run it again. And it says unknown option M. Is it M? Okay, let me check my... Oh, okay, that's right, because we didn't finish the code. Okay, so there's a to-do line in here, which we haven't done yet. So there's a bunch of to-dos in here that we've got to fill in before it can finish using this. Okay, so it says, hey, we've got to fill in, there's a to-do here, we've got to fill in these two lines. So what it's going to be is, and there's an example of this in the Lab 1 files. There's a large command line sample that has how to do this. It's got some examples of some that already are written in there. Let me see. Is this readable, or should I make my font size here a little bit bigger? Bigger? Okay, now if I could only remember the... Nope, that's not it. I got to remember. I don't remember my function key for that. So let's see. Tools, options. I know there's a hotkey for make the font bigger. I don't remember what it is by default. Okay, better? Okay, so we got to fill in a to-do here. So what we're going to fill in is, we're going to put in a curly braces here, and what we need to give it is the long version of the command. So it says, hey, we've got to fill in mode M. Okay, so mode is going to be the first one. It's going to have a required argument. We'll get to that in a minute. Required argument, a null pointer, and then the last thing is going to be the short version, M. So we've got M added in there. We'll add a comma after that. and we'll add in the help line. So help is an option. It's got no argument, null pointer, and the short version is H for help, and put a comma after the curly braces. So we've got our 2 lines filled in for this to do. There's another to do down here. So let's look at this first one, mode. The way this sample program works is you can say -m would be one way to do it, or you can say minus mode. There's a long version, there's a short version, and then after the m or the mode, you have to give it a word such as no size. And so the fact that this word is required, if you say -m, it is required that you put another word after it. So that's what it means by required argument. If you say -m or minus mode, it must be followed by another word. Whereas help is not followed by something else. Help occurs all by itself. It doesn't have any extra words with it. So we've taken care of the long and short versions. This is one thing that's sort of poorly designed in C++, is we have to, down here inside of double quotes, we have to basically make a short version that matches the short version up here. So we could say MH to say, hey, those are the short versions of the options that I've created. However, one other thing, because M has a required argument, you put a colon after it. So this is something that I know there's a lot of details here. It's a little bit tricky at the start. Once you do it once, you're going to be copying and pasting this into other projects. You'll copy and paste like your project 1 options into project 2, and then you'll do something like I've seen students do. You'll fix the long options, and you'll forget to change the line in double quotes, and you won't realize why the heck it doesn't work. But with a little bit of practice and doing this once or twice, you'll get used to it, copy, paste it, modify it, you'll be good to go. So if we look on Canvas in the Lab 1 folder, Lab 1 has a bunch of starter files. Oops, just Lab 1. Lab 1 has a get-opt large example. There's a whole example in there already done completely. You can look at it also as a reference when you're doing this. Okay, so I've got my options in here. Let's try rebuilding it. Builds, let's try running it. And it says you've got no data, so you got no statistics. So it ran, it just didn't have anything that could read from. So we've got to go back to our command line. So we right-click Project 0, Properties, and the debugging command line arguments. Now, what we're going to do here is we're going to redirect the input from one of our sample files, sample-n.txt. I can't type. So this is, what we're doing here is we're telling Visual Studio, hey, when you run this program, don't read from the keyboard. I want you to read from this file. And we can do that at the Unix prompt. We could say, hey, when I run this program, redirect it from sample-n.txt. So we can do that on the Unix prompt. We can do it in Visual Studio. So like I said, every IDE has a problem. Visual Studio's problem is that get-opt doesn't come with it. Xcode's problem is that redirecting input takes 3 extra steps to get that working. Okay, so now when I run it, it still says there's no data. Okay, let's look further in here. There's more to-dos in here. Ah, to-do, write this function. So I'm supposed to write a function for read with resize. I'm supposed to write a function to read with reserve. And I'm supposed to write a function that reads with no size. So since I already did the command line option, -m, mode, no size, let's write the code that's supposed to go in this function. So right now it says, hey, there's a line of code in here. You should delete this when you're done. We put this line of code in here just so it would compile when you got it. If we didn't do this line of code, we'd get a compiler warning. So we don't want to get rid of that. So we're going to get rid of this, and we've got to do what it says this function has to do. So it's got to use a while loop to read in the values, store them into the vector, using data pushback. Okay, so I've got a vector of doubles. I'm going to need a double, let's call it value. I've got to have a double value. And then I've got to read, I've got to use a while loop to read in those values. Now, if you've had a class that's told you, use a while loop that reads while you're not end to end of file, do not use EOF. Reading until EOF is true is the wrong way to do it. What we're going to do instead is we're going to say while you can read from CN into that value. So this while loop is saying as long as the read succeeds, keep going through. If it reaches end of file, the read will fail. If it encounters a string when it expects to see a number, the read will fail, the loop will stop. Really, really simple. Now notice here I'm reading from CN. This program is, even though we're reading, remember I said we're going to read from a file named sample-n, the operating system is going to take care of this for us. When we say redirect input, the operating system says, hey, instead of hooking the keyboard to CN, why don't you hook this file on hard drive to CN? So this is going to make our lives easier. When we want to read from a 10,000 line file, we don't have to retype 10,000 lines. We don't have to copy and paste 10,000 lines. We just say, read from the different file. So our program is just going to read from CN, but the operating system, or Visual Studio, is going to hook that input file into CN. So while I can read from CN, I'm going to say data, push back, and you can see Visual Studio will start filling things in for me and give me a little pop-up help. Push back that value, semicolon. So that's it for this function. We've taken care of the to-dos if we specify the no size flag. So let's compile that. It worked. Run it. And look at that. Now the program did something useful. It read a bunch of doubles from the input file. It showed me the average, and it showed me the median. And the Project Zero spec will tell you, hey, I believe it says what the right values are. So anyway, the right values will be in the video. So now we've gotten one of those three options working. So there's read with no size, read with resize, read with reserve, to get used to these ideas of resizing and reserving a vector. So if we don't do any sizing of the vector, if we just say push back, do any of you recall how a vector grows? Yeah. Yeah, it doubles every time. Now that could be a problem. What if there were, say, 4,100 lines in the file? Doubling, we'd get up to powers of 2, 2,048, 4,096. But because there's 4,100 lines in the file, when we read the next one, the vector will double from 4,096 to 8,192. We'll have room for 8,192, but we'll only be using 4,100 of them. So reading without knowing the size up front can waste memory. So the other two versions of the file, which, hey, let's look at them. The other two versions of the file, we can actually open these files up in Visual Studio. We can say under Resource Files, add something that's existing. Let's look at sample R and open it up. So sample R, notice the very first line has a number, 127. Everything after that is a double value. So this one, the first thing you're going to read from the file is the size, and then you will either resize the vector or reserve the vector to be exactly the right size, and then you'll go and read that stuff in. What's the difference? What's the difference between resizing a vector and reserving a vector? Okay, so if I create a vector, let's go back over to our notepad over here. If I create a vector, I just say vector of doubles data. Okay, that vector is of size 0 out of 0, meaning it doesn't have anything and it's got room for nothing. If I do a pushback, Now it's at size 1 out of 1. And now I'm going to copy this line a couple times. So if I do that a couple times, then it'll be at 2 out of 2. Then it'll go to 3 out of 4. And then it'll be at 4 out of 4. And if I do it again, its new size would be 5 out of 8. Now, if we were to say, let's just, before we do all of that stuff, let's say I say data dot resize to 10. Data dot resize of 10 says your new size is 10 out of 10. So resize affects both values. There are 10 values and there are room for 10. What are the values of those 10 values? 0. Yeah, it's filled with zeros. And if I go pushing back into that vector, it'll grow. I'll have 10 zeros followed by the data from the file. So that's not good. So if I use resize, then what I want to do is I just want to read with square brackets. I want to read into data sub I and just keep incrementing I. Now, that's what happens with resize. If instead, let's say I did my data vector and I said data.reserve 10, this one says you're at size 0 out of 10. You don't have anything in you currently, but you have room for 10. You can now push back 10 things before you have to grow. So if you do a reserve, then you do want to do pushback. You want to go to 1 out of 10, 2 out of 10, 3 out of 10, etc. So you use resize if you want to make it 10 and use square brackets to put things in there. You use reserve if you want to make it the right size, but then use pushback to grow it along the way. So that's the things you have to do with these other two functions. With the read with resize and read with reserve, hey, it's got a list of instructions, what you've got to do. Read in the size, use the resize, use a loop, etc. Okay, so that's it for Visual Studio. So like I said, we're going to have Professor Darden's going to do Xcode, and we're also going to stick around after that for some questions. So you ready over there?
Yep.
Okay. Let me just get out of your way.